test 2 practice. There are 30 questions in this practice assignment. So let's start. Graph the function y equal negative e to the power negative x over the interval negative 3 comma positive 3. So first of all, you have to know the graph for e to the power x. So we already know that graph for e to the power minus x, it should look like this. Okay, so but in this case we have negative of that, so it's a reflection about the x-axis. So this is the graph we're going to get. Okay, so this is what we're going to find, and when x is 0, as you can see that one testing point, the value would be 0, right? When x is 0, okay, no, it should be negative 1, because e to the power 0 is 1 and there is a negative sign, so it should be negative 1. So we are looking for the graph which look like this, this bottom one, and so A and D are not right choice, and then B and C, from B and C, as you can see, if you compare, B is the right choice. So that is our answer. Write the equation in equivalent logarithmic form. So you can say if you have this thing, then there is an equivalent relation a to the power x equal y is equivalent to x equal log base a y. So you can always go from exponential form to logarithmic form. So here the base is b, and then on the exponent you can see there is z, so the equivalent form would be z equal log base bm, z equal log base b, and then capital F. Find y without a calculator, so we can use the same equivalency form. We can go from log to exponential form. So if you compare this problem with this form, so the base a is 5, and then the y is 25, and so this value here is 25. So if we go from here to there, we can find out the value 25 equal 5 to the power y, 5 to the power y equal 25. We need to solve this equation, which is 5 square equal 25, right? So we can write down 5 square here, so the exponent should be equal to the exponent on the left side and right side. So we can say y equal 2. We are looking for the value of y, which is 2. How many years will it take 4,000 to grow 6,200? It's these are college algebra problem actually. You have to use this formula a equal p times e to the power r times t. This is a compounded continuous formula. So a is 6,200. That's the amount you want, and 4,000 it's your principal. You want to make 4,000 to the 6,200, and then rate is given, which is 0.0575. That's 5.75% means 0.057, and you would like to find out the time t. So just solve for t here. Just divide both sides by 4,000. I'm not going to find out the final answer here because I want you to do it. So this is 62 over 40, and e to the power 0.0575. How do you solve for t? So you can just take ln both sides. So ln 62 over 40 equal ln of e is actually 0.0575 times t. Okay, ln and e are inverse of each other. So when you take ln both sides, this is this exponent comes down here. And now for finding the t, just divide both sides by this number. So that will give you the t. Now use the calculator. Use a calculator here, and then make sure that you put the answer in 2 decimal places. So I will let you use your calculator. So just type ln 64 over 40 parenthesis close and divide it by 0.057. So I will let you do it. Okay, so find the derivative of this function. We know the derivative of ln of x is 1 over x. Derivative of exponential function is exponential function itself, and derivative of x squared is 2x, and there is a 2 already, so it would be 4x. So the basic derivative formula. Again, the derivative of 4 times x to the power e. Don't worry about this e. E is just a number. Okay, so when you use the power rule, that number e comes down, so it becomes 4 times e x to the power e minus 1 and minus 7e to the power x. The derivative of e to the power x is e to the power x itself. So this is your answer. For the first part, you have to use power rule. For the second part, it's a derivative of exponential function. Here you have log function. So derivative of log function is what is the derivative of log function? You have log base a b. So let's see, log base 2. This is problem 7. You have log base b x. The derivative of this function is actually 1 over log b times, what is that, 1 over x. Is that right? Yeah, so that is your derivative, because you can change this log base bx into log x over ln of x over ln of b, or log x over log b, and if you find the derivative of log b, that will be 1 over x. So there is a 6, so you just have to multiply this by 6, so it will be 6 over log base 2, sorry, 6 over log 2 so how do you write it? Log 2 times x. Okay, did I do something wrong here? I don't know, maybe I missed that multiplication sign here, so let's do it again. Multiplication sign. Okay, it's a 6 over x and then log 2. Okay, one more time, it's not right. What is happening here? I'm missing something here. If you have log base b of x, the derivative of this is 1 over log base b times 1 over x. That is right. In our case, b is 2 and there is a 6 on the top, so 6 over, since log base 2x is actually ln of x over ln of 2, and if we try to find out the derivative of this, okay, what I miss here, it's a 1 over ln of 2, ln of x, the derivative of ln of x is 1 over x, so times x. Okay, so instead of log, I need to use ln. So let's remove that by using ln of 2. Okay, let's try this one. Okay, 100% right. So I was using log instead of using ln. Okay, so this is the relation. We can always change log base, any base, to the ln, and we can use the derivative of ln. Okay, so find the derivative. Either you can use the product rule here, or you can just multiply them first and then find the derivative. That's up to you. I'm going to use yeah, you have to type an exact answer, so either way is fine for me. This is number 8. I'm going to use product rule. The derivative of this function is the derivative of the first one, which is 2x. Leave the second one, which is x squared plus 5, plus leave the first one, times it by derivative of second one, which is 2x. Now you can just distribute this 2x here, this 2x here, and then combine the like terms, which is 2x cubed plus 10x plus 2x cubed minus 12x. So 2x cubed plus 2x cubed is 4x cubed. 10x minus 12x is minus 2x. So simplified form is 4x cubed minus 2x. 4x cubed minus 2x. That's right. Here we can use the quotient rule. Quotient rule is if you have y equal f over z2 function, then derivative is the derivative of the top function times the bottom function minus the top function times the derivative of the bottom function over square of the bottom function. So in our case, the top function is 8x squared plus 3, bottom function is x squared plus 5. The derivative of the top function is 16x by using the power rule. The derivative of top function is 16x. The derivative of bottom function is 2x. We're going to plug this value f, z, f prime, g prime back in the formula here. So I'm going to do that. So y prime equal the derivative of the top function, which is 16x, times the bottom function, which is x squared plus 5, minus the top function, which is 8x squared plus 3, times the derivative of the bottom function. Divide it by square of the derivative of bottom function. So you can just simplify this thing if you want. Just distribute this 16. It would be 16x cubed plus 16 times 5 is 80x. Here you can distribute negative 2x. So 8 times 2 is 16. X squared times x is x cubed. 3 times 2 is 6x. Make sure that there is a negative sign, so it will be negative. So can we simplify it further? On the top there is a negative 16x cubed, positive 16x cubed, so it will be cancelled out. 80x minus 6x is 74x over x squared plus 5 whole square. So we are going to type it here, 74x over x squared plus 5 whole square. That's the answer. Let's go to the next problem. This is also, the very same idea. You can use the quotient rule, the very same formula, f over z, find out the derivative of the top function and bottom function and use this formula. The only difference is the bottom function is 7 plus ln of x, and the derivative of that would be 1 over x. That's all. And then other than that, everything else you have to do the same thing. Very similarly, you can simplify and then you can find the final answer. I'm not going to do it. That's for you to do. Here you have to find out, again, it's a quotient function. There is a function f of x. Instead of the value, that's just a notation. So you can just use the notation as is. This is problem number 11. H prime is f prime times the bottom function, which is x to the power 13 minus the function name itself, f, times the derivative of the bottom function, which is 13 times x to the power 12 by using the power rule. And then square of the bottom function would be x to the power 13 square, which is x to the power 26. So try to find out this kind of thing here. But before that, let's simplify. There is x to the power 13, there is x to the power 12. So we can just factor out x to the power 12 from the top. That will give you f prime times x minus 13 times f over x to the power 26. So we can cancel this 12, and then 26 minus 12 is the leftover would be, what is that, 14. So x to the power 14 would be on the bottom part. So very last one, you can see x times f prime minus 13f over x to the power 14. So this is the right answer by using the quotient rule. This is just a chain rule. Chain rule means if you remember, that's problem 12. If y is function to the power some integer, and y prime is n times the function to the power n minus 1 times the derivative of the function inside this bracket. Here in this case f of x is 9 plus 4 times x to the power 4. If we use that fact here, f of x is 9 plus 4 times x to the power 4. F prime is, this is 0, the derivative of 9 is 0, the derivative of this is 4 times x cubed, which is 16x cubed. So if we use this formula, n is 6, so that would be 6 times 9 plus 4x to the power 4 to the power 5 times the derivative of 9 plus x to the power 4 is 16x cubed. 16x cubed. You can just multiply 16 and 6, and then you can write down the answer, or you can just write it down as it is. We don't have any instructions, so we can just write it like this. Okay, again we are doing the same thing. Use the very similar fact we did here, the general power rule. Just use this fact n equal -5 and use everything like this. So I'm going to skip this number. Okay, so the derivative of ln function. So the one thing you have to remember or know, the derivative of log function. This is problem 14. If you have ln and then there is some function after that, the derivative of this kind of function is actually 1 over f of x times f prime of x. So the derivative of this ln and something inside the parentheses is the derivative of that thing inside the parentheses over the very same function. In our case, that is 1 plus 2x squared. So derivative of f of x in this case is 3 over 1 plus 2x squared, which is f of x. Don't be confused with this f of x and this f of x. In our problem, f of x is everything, but here this f of x means whatever comes inside the parentheses times the derivative of the function inside the parentheses, which is 2 times 2 times x. So if you simplify this, it would be 12x over 1 plus 2x whole square. So that is the answer for this one, which is 12x over 1 plus 2x whole square. Okay, let's go to next problem. Find the percentage rate of change of f of x at the indicated value of x. So we would like to find out the percentage rate of change. Make sure that the rate of change means derivative. So percentage rate of change at any point means, this is problem 15, you need to find out the derivative at that point. In this case it's a 45, and divide it by the value of the function at 45. This is called percentage rate of change. Percentage, that gives you the decimal answer, and you can just multiply this by 100, and that will give you the percentage rate of change. So find out the derivative of the function, find out the value of the derivative at 45, divide it by the value of the function at 45, and then if you want to write down that as a percentage, just multiply it by 100. So meaning go from decimal to percentage, and that will give you the percentage rate of change. So in this case, the function is 11,750 minus 5x squared, and its derivative is -10x. Now we just have to find out the value of the function at 45 and then derivative at 45. So the value of the function at 45 is 11,750 minus 5 times 45 square, which is, if you use your calculator, then it will be, let me just use my calculator here, that is 45 square times 5, and that is subtracted from 11,750. That will give me negative 1625, and value of the rate of change at 45 is negative 10 times 45, which is negative 450. So if you divide this negative 450 by negative 1625, meaning if you use this formula, that means it will be 100 times negative 450 divided by negative 1625 will be, let me just do that here, 450 divided by 1625 and times it by 100. That will give you the percentage, and we need to, it will be 27.6923, but type an integer or decimal round to the nearest tenth, so your answer should be 27.7 percentage. So the answer would be 27.7. 27.7. Oh, that's incorrect. So let me go back and check what I did wrong here. The value of the function, it's 11,750 minus 5 times x squared. So maybe I did that calculation wrong. So 45 squared times 5, and that is subtracted from 11,750, and that will be 1625. So here it's not negative 1625, it's positive 1625. So if I divide negative number by positive, that will be negative 27.7%. So instead of just 27.7%, I need to write negative 27.7%. Look, the only problem was missing that sign, or adding that extra sign. Use price demand equation. So this is the equation between the price, which is P, and the demand, which is number of items X. This equation is called price and demand. And now we need to find EP, which is elasticity of demand. There is a formula for finding the EP, so I'm going to write down that formula here. Let me just add a couple of extra pages here, blank pages, so that we can use while doing the problem. Okay, so let's go back here. So elasticity of demand, this is problem 16. EP, that is also called elasticity of demand, can be found by using this formula: negative price times the rate of change of this demand function f of p divided by the value of that demand function at that price. So this is what we need to find elasticity of demand means. So if you look at the function here, that's f of p is that's 190 minus 55 ln of p. If we try to find out the derivative of this function, the derivative of first part is 0, the second part is 55, the derivative of ln of p is 1 over p, so it's a negative 55 over p. So EP is, if we use that formula, negative p times negative 55 over p divided by the value of the function at p, which is 190 minus 55p. So this p and this p cancel out. You can cancel this negative and negative, and that will be positive 55 over 190 minus 55p. So the answer is 55 over 190 minus 55p. They are not asking us to simplify it, so I hope that this is the right answer, but okay, this is not. So what did I miss here? Simplification or negative sign? 55 over 190 minus 55p. Okay, I did not miss anything. Negative p times, so f of p is 190 minus 55 ln of p, and then derivative is negative 55 over p. The formula is negative p times f prime of p, so which is p is gone. So let's simplify. Let's plug simplified answer. Okay, so simplified is, there is a 5, you can write it down, 5 times 11. On the bottom part you can factor out 5, which is 38 minus 11p, and we can cancel this 5 and 5, and answer would be 11 over 30t minus 11p. So let me just do that here. 11 over 38 minus 11p. Let's see. Again, it's wrong. I'm not so sure why it's wrong. 11 over 38 minus 11p. Let me check my formula. Okay, so I will just check the formula. Okay, so let's go back. I found the problem here. The problem is when I was plugging the value, instead of putting f of p, look at here. The f of p is 190 minus 55 ln of p, but I was just putting 190 minus 55. I was missing ln here. So we need to put ln of p instead of ln. This should be ln of p. So the answer should be, 11 over 38 minus 11 ln of p instead of just p. That was my mistake. So I tried to do another problem, so it just gave me different numbers, and then I realized that I was missing ln. So let's do one more time here. But this time the function is different, so but we're going to use the very same formula. So this time let's say f of p is 185 minus 55 ln of p, and then f prime of p is it's negative 55 over p. So ep is, if you look at the formula, it's negative p times f prime of p over f of p. I was missing I was wrongly putting that value of the function. I was missing ln, so this time this is negative p times f prime of p is negative 55 over p, and over f of p is the function itself, which is 185 minus 55 ln of p. So I'm not going to miss this time. So this negative and this negative cancel, this 55 and 50, p and p cancel. So the answer is 55 over 185, 55 over 185 minus ln of, minus 55 ln of p. So this time the answer is right. So I was missing this ln. Let's go to the next problem, the price demand equation. This is the price and demand equation, meaning the relation between the number of item X and then price of that item P. That's called price demand equation. For an order of fries at a fast food restaurant is given by the equation here. What price will maximize the revenue from selling fries? So we are trying to maximize the revenue. So first of all, we need to write down the revenue in terms of price, because it's a what price. So look at here, problem 17. We know the revenue uh, can be found by multiplying the number of items times price. So in our case, we need to express this revenue as in terms of price. So we are going to change this x to the p by using this relation. So we know x plus 1500 p equal 800. So we can write down x as a negative 1500 p plus 800 by subtracting 1500 p from both sides. So we can change x into p in this revenue function. So the revenue would be, instead of x, we can write down it's a negative 1500 p plus 800 times p. P means price. Okay, so the revenue here, you can see that it's a revenue it's a function of price. I can write it down like this. It's just a notation. You can write just r, but I'm just changing it as rp, meaning the function of price is negative 1500 p times p is p square plus 800p. It's a function of price. So we would like to maximize this revenue. So for the maximum or minimum value, we can use the second derivative test, meaning we can find out the derivative of this function, find out the critical number, find out where the second derivative is positive at that critical number or negative at that critical number. If the second derivative is negative at any critical number, then that is the maximum value. So let's do that. First find out the derivative of this function, which is negative 1500 times 2p, which is 3000 times p, plus 800 because derivative of p is 1. And then if you equate this to 0 and solve for x, that will give you the critical values. So that is negative 3000 p plus 800 equals 0. And if you solve for p, that will be 800 over 3000. So this 0, it's gone. So it is 8 over 30. 8 over 30, if you use your calculator, that will be it's 8 divided by 30 is 0.26. So we need to round our answer to the nearest cent. So just for now, just write it down. It's a 0.26. Okay, but we still have to make sure that at this price we're going to get maximum revenue. For that, we need to find out the second derivative of this revenue function, which is going to be negative 3000, which is negative. So according to the second derivative test, a function would be maximum at any critical point, like here it's a 26 cents, if the second derivative at that point is negative. But for this particular function, second derivative is always negative. So the meaning is second derivative at 0.26 cent is also negative. So the meaning is revenue would be maximum. Revenue R is maximum, will be maximum when price is 0.26 cent, if you round it to the nearest cent. So I'm going to put it here. It's a 0.26, meaning 26 cents. Okay, one more time. This is not giving me. Why is that? Round to the nearest cent. What did I do wrong? So if I divide 8 by 30, that will be 0.266. Oh yeah, so that is there is a 6 after 6, so if you round it, it will be 0.27. It's a 0.27. It should be 27. My rounding was not right, so make sure that when you give the answer, try to double check your final answer. Okay, look, it's 100% right. Before it was not correctly rounded. If we divide 8 by 30, it is 0.266666, and if you want to round it to the nearest tenth, it would be 0.27. Okay, next problem. Finding the derivative is not big deal. It's just a power rule, which is 3x square minus 75x, and then derivative of 75x is just 75. Partition number means find out where this derivative would be 0, and then on the left side and then right side of that number, just check if the derivative would be positive or negative. So in this problem, let's say this is problem 18, the derivative is 3x square minus 75, and we try to find out where this derivative is 0, and that means 3x square minus 75 equals 0. And then if we just solve for x, that will be positive 5 and negative 5. These are the 2 points where the function would be positive, where the derivative would be 0. So these points are actually called partition points. So it is a negative 5 and then positive 5. And then critical number means any number where the derivative is 0 or does not exist. So but we don't have anywhere this derivative does not exist. So in this case, the critical number are same as partition number. Okay, sometime your derivative you also have a point where the derivative does not exist. You also have to include that point here. But in our case, partition number and then critical number, for this particular problem, they are same. Partition number means the number which divides the derivative. If you go to the left side, it may be positive derivative or maybe negative derivative. Here maybe positive, negative. here maybe positive, negative, but these are the points which is dividing that positivity or negativity of the derivative. That's why they are called partition number. Okay, so look at the table and find out which one is the right graph. And this is not a very difficult problem. Just look at the value of the function, and then it will help you to reduce your choices. For example, the value of the function at -4 is 16, so positive 16, and then at 0 is 0, and then at +4 is -16. So for the first one, as you can see that either +4 or -4, either on the positive side or negative side, both of the value are positive, so this is not the right choice. Again, this one, C, either for the positive value or negative value, the value of the at negative or positive, the value of the function is negative for both sides. So A and C are definitely they are not the right choices. So now if you go from B and D, for the B, to the left side it's positive, to the right side it's negative, but for this D, to the left side it's negative, but it has to be positive. Look at here, when the value of the function at -4 is positive 16, it has to be positive 16. So this is the only one choice. You can already choose your answer just by looking this one choices you have given. Even you don't worry about the derivative. Okay, but if this is not enough, then you go to the next step and you see about the derivative of the function, where it's 0, where it's increasing, where it's decreasing, and then you choose your right answer. Okay, so we have to answer some of the question based on the graph here. The graph is given, and then the first question is, on what subinterval the derivative is positive? Derivative would be positive when graph is increasing. So as you can see that the graph is going up, 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 up to this point, and then after that it's going down, and then again it's going up. So the derivative would be positive until -1, and then it will be positive after +1. As you can see here, it's increasing, meaning derivative is positive. It's decreasing. If you zoom in, then you can see that whenever the graph starts decreasing, that means derivative is negative. So the answer for the first one, you can see that it's up to -1 from -infinity and after +1. So the answer is the derivative would be positive from -infinity to -1. And if you have more than one interval, just separate them using the comma. That's what instruction says. So we're going to just follow the instruction here, 1 to +infinity. That's where the derivative is positive. The second question, on what subinterval the derivative is negative? We already answered that question. It's from -1 to +1, from -1 to +1, where the derivative is negative because the graph is going down. For which value of x the derivative is 0? The derivative would be 0 where the tangent line, you will have a horizontal tangent line. As you can see that at -1, if you draw the tangent line, it will be the horizontal tangent line, and at +1, if you draw the tangent line, it will be the horizontal tangent line, meaning the derivative is 0. So the derivative would be 0 when x is -1 and then +1. Now based on this information, we know that to the left of -1 the derivative is positive, to the right of +1 the derivative is positive, in between -1 to +1 the derivative is negative. So we need to, based on those information, we need to choose one of the graph for derivative. So this one, it's negative. Look at here, it's negative to the left, but it should be positive. Look at here, it should be positive to the left of -1. So this is not the right choice. And then again here, the second one, it should be positive, but here you have negative answer, negative value. So this is not the right one. And then if you go here, choice C, from -infinity to this point, it's positive, but after that point it's negative. So this is also not the right choice. The only right choice is the last one. If you match the information we got here with the information here, it will be easier for you to find out the right graph. So up to -1 the graph is positive. That means the derivative is positive because we're looking for the graph of derivative. So this is the graph of derivative of the function. So up to -1 the graph is positive. At -1 it's 0. From -1 to +1 the graph is negative, and from +1 to infinity the graph is positive. So that's the reason this is the right choice. Okay, inspect the graph of the function to determine whether it is concave up, concave down, or neither. Here's the ways you can solve this problem. So graph would be concave up if, let's say, this is the function, and if the double derivative of that function is positive, graph would be concave up like this. The double derivative, second derivative is negative, meaning that the graph would be concave down. So in our case here, the function is n of x, which is square root of -3x. If you find the derivative of this function, it would be -3 over square root of -3x. Just use the power rule, and then you will be able to see that. So eventually this is -3 over square root of -3x. That's the first derivative, but we also have to find out the second derivative. So let's find out the second derivative. Second derivative is, again, this will be +3 times 3 over square root of 1 over 2. I also missed that thing here. It's 1 over 2 -3x. So here it's a positive. If you don't know how to find out the derivative of this -3x, this is actually -3x to the power half. Now just use the power rule. Just treat this -3x, -3 as a number. Then you will be eventually find out this thing. Here is a 2 as well. So this is a 9 over 4 square root of -3x. Make sure that this is always positive, and then 9 over 4 is also positive, so eventually it's going to be positive. If the second derivative is positive, then the graph would be concave up. Okay, did I miss something here? If the second derivative is positive, then graph should be concave up here. So first derivative, okay, oh yeah, I missed something here. The first derivative is -3x, but the second derivative would be, again, there will be one, there will be one negative here, because uh, for the first time the half power was on the top, but the second time that half power comes on the bottom. So that will, let me just show you how to find the derivative, from the it looks a little confusing here, so don't be confused. I don't want you to be confused. Okay, so what is that? Let me just find out the derivative here. Okay, so n of x is, it's a -3x to the power half. N prime of x, it's the power rule 1 over 2, -3x. Half minus 1 is -half, times the derivative of the function inside this parenthesis, which is -3. That's why it's a -3 over 2, -3x to the power half. The second derivative, if you try to find out the second derivative, you have to find the derivative of this one, which is half times -half times -3x to the power -half minus 1 is a -3 over 2, times, there is a -3 from here and a -3 from here, that will be -3 square. So eventually that will be negative 1 over 4. 3 square is -3 square is +9, so -3x over 3 over 2. But remember, don't be confused, this is positive value, okay? So eventually this is 9 over 4 negative 3x to the power 3 over 2. This thing would be always positive on this domain, the domain we have given here. If you look at the domain here, it's always positive. So because of this negative sign, it will be negative, and because of that fact, the graph would be concave down. Because second derivative is negative, the graph would be concave down. So for this particular problem, the graph would be concave down. Okay. Next problem, find the interval on which the graph of function is concave upward. So, find the first derivative, find the second derivative, find the, points where the second derivative is 0, find the points where the second derivative is positive, and that will help you to find out where it's concave up and where it's concave down. Okay, so let me just add some pages here. So let's go back here. The function is given. The function is given. The function is given. The function f of x is a polynomial function which is negative x to the power 4 plus 20x cubed minus 20x plus 2. Find out the first derivative, which is by just using the power rule. And 3 times 20 is 60, and then this is 20. Find out the second derivative. Whenever you try to find out about the concavity, find the second derivative, and then that will be 4 times 3 is 12x squared plus 60. And now, because you want to find out where the second derivative is positive or negative, first of all find out where this second derivative is 0. So solve this equation. That is your partition points, that is your inflection points actually. And then if you solve it, x squared equal 5, because 60 over 12 is 5, and x equal positive and negative is square root of 5. These are the 2 points where the second derivative is so there is a negative square root of 5, there is a positive square root of 5. We know that at these 2 points the second derivative is 0. So to find out the concavity, we need to find out what happens to the second derivative on this interval, and on this interval, by choosing some some testing point. So we are going to choose some testing point from here, and then we're going to find out what happens to the second derivative on this interval. So let's choose from here. Square root of negative 5 is it's less than negative 2, so let's choose from here it's negative 3. From here let's choose 0, and from here let's choose 1. And now find out the second derivative at these 3 points. So second derivative is negative 12 x squared plus 60. So second derivative is negative 12 x squared plus 60x. Did I miss something here? I think I missed something here, so I'm going to go back here and check my second derivative. Yes, I did miss something here. The derivative of first derivative is 60x squared. I missed square here. And the second derivative would be negative 12x squared plus 60x. So when I try to find out, when I try to solve this equation, this is not the right one. Okay, so let me redo it. It's a negative 12x, and then which is x plus 5 equals 0. Okay, x plus 5 equals 0. So if we solve it, it gives me two options, 0 and negative 5. 0 and negative 5 are the 2 points where the second derivative would be 0. So my points are 0 and negative 5. So now I need to pick the points from here. So let me pick negative 1. From here let me pick sorry, negative 5 comes here, 0 is here. So I'm doing this mistakes here. So I would just tell you, just be careful while solving the problem in the exam, because you might repeat the same kind of mistake. So don't repeat this kind of mistake while taking the test. That's why you have to do this practice test, a couple of times to make sure that you don't repeat that mistake here in the test. So -5 is here, 0 is here. So let's pick the testing point. From here, let's pick -6. From here, let's pick -1. From here, let's pick, let's say 1. And then second derivative is, if you go up, it's a -12 times x plus 5. So if you try to find out the value of the second derivative at -6, it will be negative, because -12 times -6 plus 5 is 72, and -1, which is -72, which is negative. So here the second derivative is negative, so that means the concave down. Let's pick the second derivative at -1. At -1, the value would be, again, it would be negative, because it's a -12 times -1 times, no, it should be positive. Okay, so if after plugging the -1, it gives me 12 times 4, which is 48, which is positive. So that means the graph would be concave up on this interval. And by doing the same thing, if you plug x equal to 1 in the second derivative, you will be able to find -12 times 1 plus 5, which is 6 times 12, which is -72. Again, it's concave down. So we found the concavity of this curve by using a second derivative test. So for what interval of x in the graph of f concave upward? So the interval is, as you can see, it's concave upward from -5 to 0. So -5 to 0, -5 to 0. For what interval of x the graph of f is concave downward? There are two different intervals, which is -infinity to -5, and comma. They say separate your answer by using comma, 0 to +infinity. So let me just double check. It's a concave downward from -infinity to -5 and 0 to +infinity. Finally, determine the x coordinate of any inflection point. Remember, inflection point means where the derivative is 0. The second derivative is 0. That gives you the inflection point. Or where the second derivative does not exist. Or, inflection point is a point where the graph changes the concavity. So as you can see here, the graph is changing concavity. Graph is concave down up to -5, and then after -5 it's concave up. So it's changing that concavity. So -5, and then same thing happening at 0. -5 and 0 are inflection point. So -5 comma 0 are the two inflection point. 0%. What did I do wrong here? So let me go back and find out one more time. Did I miss something? My function is let me go back here. -x to the power 4, 20x cube, -20x plus 2. First derivative is -4 times 3. Oh, 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 okay. I totally missed something here. I did mistake for finding even the first derivative. No, -4 times x cubed. That's right. 20 times 3 is 60, x squared minus 20. That's right. So first derivative is perfectly right. Second derivative is -4 times 3 is 12. That's cool. X squared plus 60 times 2 is 120. My bad. 120. So that means it should be not 60, it should be 120. That's the mistake I did, but the rest of the work should work. So 120, so that means whenever you factor out 12x, it should be x, because you are factoring out negative, so there will be negative. So everything changes, x minus 12 times 10, so it should be 10. So the two of the answer is 0 and positive 10. I'm really sorry about that. So 0 and 10 are the two options where now we should check everything, from the beginning, 0 and 10. So from 0 and 10, okay, let me redo it. It's a lot of work. Okay, I check it and then a lot of work. So this is the very same idea you are going to repeat, but so let me just delete everything from here. So 0 and 10, so find out the testing point. Let's say this is -1, testing points, let's say 1, and then 11, and find out the second derivative at -1. I'm not going to do the same work again, but the second derivative is here, which is -12x x minus 10. So at -1 it would be positive negative, so it would be negative, so it would be negative. At positive 1 it would be positive 1, negative times negative is positive, so it will be positive. At positive 11, as you can see here, this expression would be positive, but this will be, because of this negative, it will be negative. So you can find out this value the way we found for the previous points. Instead of 0 and 10, we found it for -5 and 0. That was my bad. So these are the points, inflection point 0 and 10, and rest of the thing, they don't change. It's concave down, concave up, concave down. So instead of -5, I'm going to write it down as from 0 and 5, 0 and 10. So here it's from -infinity to 0, and from 10 to infinity, and the points are 0 and 10, 0 and 10. Okay, look, that's 100% right. So my bad, I did mistake while finding the second derivative. So make sure that when you do your work, you just have to be very careful. I'm not taking the exam, but when you take the exam, this kind of mistakes, that would be very big penalty. So make sure that you double check your work. Okay, so let's go to the next problem. This is very similar question. We have a function. We need to find out the x and y intercept. We need to find out where the function is local maximum and then inflection point. So again, we need to find out the second derivative, and x and y intercept means let me just do this one. This is problem 23. This time I'm going to be double careful. The function is 7 times x to the power 4. When I'm doing this problem, I'm trying to save time so that my this video would be shorter. That's the reason I do it fast, but you don't have to do that. You have enough time while taking the test or taking this practice test. Okay, so for finding the y-intercept means when x is 0. So this is your y-intercept, which is 7 times 0 minus 42 times 0 is 0. For finding the x-intercept, you have to make f of x equals 0. So solve that equation. So the y-intercept is 0. Y-intercept is 0. And then x-intercept is, solve this equation, which is 7x to the power 4 minus 42x squared equals 0. I can factor out 7 times x squared, which gives me x squared minus 6 equals 0. And then here I can solve either x equal to 0 or x equal to positive square root of 6 or negative square root of 6. So these are the three x-intercepts. So you can write negative square root of 6, 0. I'm just making this in order, but we don't need to write it down in order according to the instruction. There is nothing about order. Okay, For finding the local maximum or local minimum, we're going to use second derivative test, meaning we need to find out critical points, we need to find out the second derivative, and we need to find out where second derivative is positive and where second derivative is negative. So for that, so find out the first derivative. The function is this one. So first derivative of this function is 7 times 4 is 28x cubed minus 42 times 2 is 84x. And then second derivative of this function is 3 times 28 84 x squared minus 84. That's the second derivative. So find out the critical points. Critical points can be found by equating this first derivative with 0 and solving for x. That gives us critical number. So if we do that, 28x cubed minus 84x equals 0. Now solve for x. So we can just factor out 28 and x, which is x squared minus 28 times what is that? What is the common factor between 28 and 84? It's a 3, right? So it's x squared minus 3, because 28 times 3 is 84. So if you solve both this, one of the answer is 0 and other two answers are x squared minus 3 equals 0. So it's square root of negative 3 and square root of positive 3. So these are the three critical points. Where we need to check the value of the second derivative. So let's do that. So second derivative is 84x squared minus 84. Let's go back here again to double check. It's 84x squared minus 84. So I can factor out 84 and I can just write it down like this. It would be easier for me to see where this function would be positive or negative. Second derivative at 0 is this becomes 0, so it will be negative 84. It's negative, so if second derivative is negative, the function has maximum value at 0. Second derivative negative means the function has at this critical point the maximum value. Okay, and then if second derivative is let's check for the negative square root of 3. It's 84 times square of negative square root of 3 is 3 minus 1 is 2, so that is positive. So at this point the function has local minimum. Okay, because second derivative is positive means local minimum. Similarly, if you try to find out the value at positive square root of 3, the same thing will happen. It's 84 times square root of 3, which is 3 minus 1 is 2, which is again positive. So at 0 it's a local maximum, and at these 2 points it's a local minimum. Okay, so the local maximum is at 0, and then local minimum is r at negative square root of 3 and positive square root of 3. And then inflection point means where the second derivative would be 0. If you just equate the second derivative, as you can see that second derivative is this one, and if you equate the second derivative with 0, that's where you find the inflection point. Second derivative equals 0, which means 84 times x squared minus 1 equals 0. If you solve for x here, x is positive 1 and negative 1. At 2 points, second derivative is 0. So that means inflection point are negative 1 and then positive 1. Okay. So now we need to find out where the function is increasing. For finding this information, we need to use first derivative. First derivative is 0 at 3 points. These are the critical points, and we need to check where the function is the first derivative is positive, the function is increasing. Where the first derivative is negative, the function is decreasing. So we go back here. These are the 3 points. Let me double check either that is the right points or not. I don't want to spend time and then finally get the wrong answer. So this is the function, and then first derivative is 28x cubed minus 84x, and then if we solve that one, 28x cubed minus 84x, 28 factor out, so that means mhm, okay, so that is 28x cubed minus 84, and then I factor out 28, that will be so that is -3. That's right, that's right. So okay, so that is right. So at 0, negative square root of 3 and positive square root of 3, this first these are the critical points. They are partition points as well. We need to check where this function, where this first derivative, which is, if we go back, the first derivative is, it's a 28x times x square minus 3, 28x times x square minus 3. So if you pick anything from, the left side of negative square root of 3, for example, let's say negative 5, then this value, the first derivative, just focus on here. You don't need to find out exact value. If you know either it's positive or negative, the whole expression, then that's enough. Something from here, which is, the square of that would be greater than 3. So that means this would be positive, but this would be negative. So the first derivative would be negative on this interval. You can always check that. If you don't see that thing, just take the testing point. And from here, let's say you are picking -1. So -1 square is +1, minus 3 is -2, and then here is a negative, so that will be positive. So that means first derivative is positive. From here, let's take 1. 1 means it's a negative, because 1 minus 3 is negative, so it's a negative. And then here, that would be something greater than let's say 3. So this would be positive, this would be positive, so first derivative is positive. So the meaning of this thing is, on this interval the function is decreasing, on this interval the function is increasing, decreasing and increasing. Okay, wherever the first derivative is negative, the function is decreasing. Wherever the first derivative is positive, the function is increasing. So we found that thing here. So the function is increasing on, as you can see, that from negative square root of 3 to 0, and from positive square root of 3 to infinity. That's where the function is increasing. So the function is increasing from negative square root of 3 to 0, and type your answer in interval notation. Use a comma to separate answers. So we have to use the comma here. Square root of 3 to infinity, square root of 3, um, square root of 3, square root of 3 to infinity, infinity. That's where the function is increasing, because the first derivative is positive there, and then decreasing here. So that is from negative infinity to negative square root of 3. That's where the function, the first derivative is negative, and then here, which is 0 to square root of 3. Okay, 0 to square root of 3. That's where the function is decreasing. Okay, now we need to find out where the function is concave up, concave down, and that information is already found. If we go back to the second derivative here, we found the second derivative, and we know that second derivative is second derivative is, okay, at 0, negative square root of 3 and positive square root of 3, you can see that it's a negative. So f is concave upward. So where is the second derivative? Where second derivative is 0? Okay, here the second derivative would be 0 at +1 and -1. So we are going to check where this second derivative is positive or negative. So remember, second derivative is 0 at +1 and -1. We need to check on this interval, on this interval, and on this interval. But for that, if you check the second derivative, that second derivative value is, which is 84 times x squared minus 1, meaning it's 84 times x squared minus 1, which can be written as 84 times x minus 1 and x plus 1. So now if you try to check the value of the second derivative on this interval, which is less than -1, this will be negative, this will be negative, so negative times negative is positive, so second derivative is positive here. If you check something, if you take something from here, let's take 0, then since 0 minus 1 is negative, 0 plus 1 is positive, it will be negative. Finally, let's take something from here, which is, let's say 2. 2 minus 1 is positive, 2 plus 1 is positive, so it's positive. So the meaning, the graph here is concave upward, here it's a concave downward, and here it's concave upward. Okay, so function is concave upward on from negative infinity to -1, and there are two intervals where the graph is concave upward, from 1 to positive infinity, from 1 to positive infinity, and then it's concave downward uh, from -1 to +1, from -1 to +1. That's concavity is coming from the second derivative test. And by using all this information, you can choose the right graph here. We know that from negative infinity to -1 the graph is concave upward, and from 1 to infinity the graph is concave upward. From -1 to +1 the graph should be concave downward. So if you look at here, the first one from -1 to +1, this is 1, this is -1. From -1 to +1 the graph is concave downward. To the left side of the -1 it's concave upward, to the right side of the -1 it's concave upward. Yeah, that's right. But let's look at other options as well. This one, from -1 to +1 it's concave upward, but it should be concave downward, so this is not the right choice. Here, from -1, where is the -1? This is 0. So from -1 to +1 it's not concave, it should be concave downward, but it's not, so this is not the right choice. Finally, this one, from -1 to +1 it's not concave downward, it should be concave downward. So this is the only choice which matches this concavity test. You also have so many other information which will help you to find out the right choices. Hopefully I did it right. Did I? Why it's not giving me the option here to click? Did I click the right? Did I miss something? So let's go back here. Okay, the first one, what is the domain of this function? The domain is, because it's a polynomial, so the domain is all real number, so it is from negative infinity to positive infinity. There is no restriction. So now I can check my answer. 100% right. It's a long problem, so I was somewhat worrying if I miss somewhere something, then I need to go back and fix it, but I got lucky. It's right. Okay, let's go to the next problem. The next problem is, again, it's the same thing. You need to find out the local maximum and where function is concave up, where function is concave down. So I'm not going to repeat the same thing. I'm just going to give you idea. Here, this is the price and demand function, price and then demand, and this is the revenue. R of x is x times p. Now we need to find out the local maximum or local minimum of this revenue by finding the first derivative and second derivative, and by finding the critical numbers, and we need to find out where the second derivative is positive, where the second derivative is negative, exactly the way we did the previous problem and before that. So this is the once again, I'm not going to repeat it. Instead of this function f of x we use in the previous case, just use exactly the same thing, but you have this one, R of x, and you will be able to find out where the function is local max or local mean, and then concave up and downward. Okay, So problem 25, by looking the graph, we need to find out find the absolute minimum value. Absolute minimum means it's the smallest value. As you can see that there are 2 points. Where are they? Yes, here, which is which is this 9.5. It's a 1 2 3 at 3, and 10 11 12 at 12 you have local you have the smallest value, and then the largest value is at 18, which is 9. Okay, so the absolute minimum value is, that is, what is the absolute minimum value? The value comes from the value of the function, which is 4. The value of the function is 4, at at and that comes from here at 3, and it's 10 11 and 12, 3 and 12, at x equal to 3 and 12. So there is that, that's the max absolute minimum value. And absolute maximum value is just one value, which is go back here one more time, it's going up, and that is the maximum value 9, which comes at 18. So absolute minimum value is 9. That's just one value, so we have to choose the second one. Minimum value is 9, and which is at x equal 18. Okay, find the absolute maximum and minimum value of this function. This is exactly the same problem we did before. For finding the absolute maximum or minimum, you can find the critical numbers, and then find the value of the function at those critical numbers, um, second derivative of the function at those critical numbers. And then one more thing you have to keep in mind, this is a parabola. So parabola means, this is parabola has either maximum value, absolute maximum value, or absolute minimum value. So find out the first derivative. So let me go to the next. Okay, I need extra page here, so I'm going to insert one more page. So okay, so I'm going to give you idea here for the absolute maximum or minimum, because we know this is the parabola, and then graph of the parabola would look like this. So there will be the absolute minimum value. We already know about that, but we need to find out by using this derivative test. So find out the critical number first. For finding the critical number, you need to find out the derivative, and then you also have to find out the double derivative. And as you can see, that double derivative is always positive. And for finding the critical number, just equate to 0 the first derivative. 2x minus 12 equals 0. If you solve for x, x equals 6. And then second derivative at 6 is positive, because second derivative is always positive. So meaning the absolute minimum value you can find out is at 6. Okay, is at 6, because the local minimum or the absolute minimum for this parabola is same. So at 6 you are going to get absolute minimum, and that is the value of the function at 6 is, just plug x equal to 6 here. So that will be if you plug the value, if you try to find out the value of the function at 6, it's a 6 square minus 12 times 6 plus 5, that is 36 plus 5 is 41 minus 72, which is what is that, 30 negative negative 31, negative 31. So absolute minimum value is negative 31 at 6, and there is no absolute maximum value. Right, let's go to the next problem. Find the absolute minimum value. This is a very similar way you can do, we did like this problem. Instead of polynomial function, now you have other kind of function, but don't worry, just find out the first derivative because by using the quotient rule. Find out the second derivative by using the quotient rule. Find out the critical numbers by equating the first derivative to 0, and solve for x, and plug those critical numbers at second derivative, and that will tell you where you'll have the absolute minimum or absolute maximum value or not. Okay, so I'm going to leave this thing for you. Problem 28, this is the application problem of optimization problem. Find the dimension of a rectangle with an area of 169 square feet that has the minimum perimeter. So whenever you try to do this kind of problem, you have to you know you have to draw a diagram if it's possible. So in this case, it's a possible. You want to find out, you want to construct a rectangle, find the dimension of rectangle with an area 169 square foot, that has the minimum perimeter. So perimeter means, let's say the one side of the one side of the rectangle is x and other side is y. So opposite side are always equal. So the perimeter is x plus y plus x plus y, meaning it's a 2x plus 2y. That's the perimeter. This is the function. uh, Now we need to find out when this perimeter would be minimum, but for that, we need to change one of the variable into another one, and we can do that by using this area. Area means it's x times y. This is given 169, so we can write down y as a 169 over x. So by using this y and x relation, I can change the perimeter as 2 times x plus 2 times y, which is 169 over x. So now the perimeter is the function of x. To find minimum or maximum, we are going to repeat the same thing. We find the first derivative and we find the critical number, which is 2 times 169 is 338 over x squared. And then to find the critical number, you have to equate this to 0, which is 2 minus 338 over x squared equals 0, which is 2x squared equals 338. And if you divide both sides by 2, this is 169, right? And x is 13, because x squared is 169, so x is 13. So this is one critical number. Okay, x is 13 and negative 13, but remember, x means it's the length of this rectangle, so we cannot take negative 13, so it should be only positive 30. So this is the critical number. We just have to make sure that at this critical number, what happens to the second derivative. If you try to find out the second derivative from here, the second derivative here, this negative, and then the derivative of x squared, 1 over x squared, that will give you another negative, so it will be 2 times 338 over x cubed. So no matter what x you pick, because x is always positive, this is positive. The meaning is perimeter would be minimum when x is 13. So but we need to find out the dimension of the rectangle. So one side is x, another side is y. We know y is 169 over x. If you go back to the relation between x and y here, y is 169 over x. So 169 over 13 is 13. So when you choose dimension as 13 feet and then 13 feet, then that rectangle will have minimum perimeter. Okay, so rest of the two problems, question number 29 and 30, they are also optimization problems. So keep in mind, when you do the optimization problem, you always have to find a function, and then after that you have to find the first derivative, and you have to find the second derivative, and that will help you to find out the minimum and maximum value. That is the thing you have to keep in mind. If you are doing optimization problem, you have to find the derivative. So let's focus on problem 29. It says a deli sells 960 sandwiches per day at a price of $8 each. So so there is a this is problem 29. Let's say this is the price, x is price, and y is number. So if the price is $8, and this is not number, it's a number of the sandwich sale. number. So that's right. This is number of cells. Okay. We need to find out the relation. That's why, you know, I'm just showing you this thing here. The price of the daily and then number, how many we shall. There is a relation between them, and that's a number. When the price is $8, you know, number of cell is 960. So $8, 960. And now the first question is, a market survey shows that every 10 cents reduction, so reduction means instead of $8, if I make it $7.90, the price, the number of cell would go up 20 more. So 960 to 980. So if I make cell, you know, price 790, the price would, you know, the number of cell go up and it becomes 980. So that's, these are the, you know, 2 points. It will give you the relation between the number price versus number of cell, and they are linearly related. Okay, so you need to find out that relation first. So let's say price is X, number of cell is sorry, the price is P and the number of cell is X. So from this we can find out the slope, and from this we can find out the relation between price and then number of cell. So what is the slope? Slope of this line, let's say M is the slope, is the difference between the y coordinate, which is 20, over the difference between the x coordinate, which is negative 0.10. So that is negative 200. That's the slope. And now if we find out the relation between x and p, then the relation would be, you know, use this formula, y minus y1 equal m times x minus x1, but make sure that y here is x and then x here is p. So y is x, y1 is one of the number, let's pick 960, slope is negative 200, x is p, and x1 is that number from that here is 8. So this is the relation between number of you know, cell versus price. So that's the price and demand function relation. So you can find out x and p. So x minus 960, just distribute this negative 200. So 200 times 8 is 1600. So you can bring this 960 to the right side. That will give you x equal negative 200p and then plus 2560. So that's the relation between price and demand. We have that relation, but why do we need this relation? To answer the next question. The next question is, a market survey shows for every 10 cents reduction in the price, 20 more sandwiches will be sold. How much should the daily charge in order to maximize the revenue? So we need to maximize the revenue. So revenue means it's a price times number of sales, so x times p. So we need to maximize this revenue. We need to find out the derivative of this revenue function, and for finding the derivative we need to change one of the variable into another one, and that can be done by using this relation. So I can write down x as a, you know, negative 200 p plus 2560 times p. So my revenue is a function of p, function of price, which is negative 200 p squared plus 2560 p. To find out the maximum value of this revenue, now we can use that second derivative test. Find out the first derivative, which is negative 200 times 2 is 400p plus 2560. Find out the critical points, which is by solving this equation. And if you try to solve this equation, you know, the p is 2560 divided by 400, which is basically if you divide 256 divided by 40, that is 6.4. That's a $6.40 is your critical number, but you have to make sure that you find the second derivative to you know, conclude your finding. The second derivative is, it's a negative 400. So that means the second derivative at this critical point, which is 6.4, is negative. So that means this revenue would be maximum. Revenue would be maximum if the price is $6.40. Okay, if the price is $6.40, the revenue would be maximum. So that is $6.40. Okay, now the second problem is very similar, but instead of 10 cents reduction, here you are doing 20 cents reduction. And just do exactly the same thing I did here. From $8, now you have to go to the $7.80. By doing that, 960 goes to 965. um, so 965, it's not a 9, because you can sell 5 more sandwiches. Okay, so by using the very similar fact, you can answer the second question. But here, just to I'm just going to put number 7. That would be the wrong answer, but I cannot check the first answer. That's why I'm just putting number 7 here to see either my first answer is right or wrong. So look at here, 50% is right. That right is coming from the top one. The bottom one, you can do the same thing. Okay, so I'm just leaving this bottom one for you. The very last problem, it's a car rental agency rents 480 cars per day. This is very similar problem like problem 29. You have to find the relation between the price and number of car. I'm going to show you the relation. After that, I will leave you to do the problem. Okay, so this is last problem. There is a price of the car, let's say a price, that is P, and there is a number of rents, that is X. So $30, if the price is $30, they can rent 480 cars. So when the price is $30, they will be able to rent 480 cars. Okay, so let's say this is the point. Now for each $1 increase, so that means if the price is 31, 10 fewer car will be rented. So that means the value would be at 31, 10 fewer. So that means 470. So this is the relation between a price and then number of car. And you can find out the equation of this line by doing exactly the same thing I did for problem 29. You can find the slope. You can use this point slope formula, and you can find out the relation between x and p. And then finally you can you know so maximize the income means maximize the revenue. You can find out the revenue by multiplying x and p, and by changing x into the p, and then you can do the first derivative test, second derivative test, exactly the same thing we did for 29, and you'll be able to solve this problem. Okay, so I'm going to leave this problem for you, and that's test 2 practice.